So let's welcome Rafał with his talk about Devise.
So let me start with something maybe a bit more controversial. As popular and often used Devise is, it has some pitfalls, edge cases, and maybe even security issues. I'm Rafał Rothenberger. I'm a bit of security freak maybe, and a software developer here at Montreal. And maybe let's start with who here never heard or used Devise? All right, that's good. Who is using in any project right now? All right, that's less actually than I thought. So it's probably more of a formality, but what is Devise? Devise is a library for authentication and user management. It provides us easy way to handle password resets, sessions, registration, all those boring things that almost every application needs. And why to use it? I would say the biggest argument here is that it's popular. It dwarfs any other solution in popularity and in features and security as well. And I know that there is the saying about popularity that flights can't be wrong, but that gives you an eyes. It's often used, a lot of people are looking at it, so it should be secure. But then, what's the goal of this presentation? Well, first I want to talk about the backward limitations. Backward is a hashing library that Devise uses, and how Devise is misusing it. Talk about how to do token-based authentication for APIs, because Devise is mostly for view-based applications, and because of how mobiles are present in everyday life, we need more and more APIs. How to do refresh tokens and why to put them in cookies. Let's talk a bit about enumeration attacks and why they're important to prevent them. And what are enumeration attacks in timing-based scenarios? So what's wrong with Backward? But before that, let's talk about salt and pepper, because I got the feedback that it might be good to give a bit of a background. So history part, in 70s and 80s, we were terrible at storing passwords. We were just hashing them and saving them to database. The problem with that was that the same password would result with the same hash. So now, when there is a leak, I can just take the most popular passwords, and breaking them will be probably easy, because if it's popular, it's weak, and it gives me the most value. And well, the second problem is when I processed one leak, I have a table with known hashes and passwords. So in the next one, I can use it. I don't have to do the whole work again. So we started using salt, which is a random string or bytes that were added at the end of the password. And as you can see, now two users with the same password, we have different hashes. It solves both of the previous issues. And in more modern hashing algorithms, we don't even append it by ourselves. We provide it as a second argument, because, for example, Bcrypt under the hood is doing much more magic with that salt than just at the end. But that wasn't good enough for us, because still, if somebody has very weak password, you can just brute force it. Use dictionary attacks, things like that. So how to secure those users? Well, we have salt, so now let's use pepper. And that's how another random element was added at the end of the password. And this time, it's not stored in database. It should be stored somewhere else. It's a secret. It should never be known to anybody. And now even if the password is password123, without the pepper you cannot check if that's the hash of that password. And again, more modern algorithms like Argon, they treat that as argument and add, instead of just adding it at the end, which is important. So let's go back to Bcrypt. Bcrypt has design decision that limits the length of the password in most implementations to 72 bytes. That means, as you can see, the password that is 72 A's and the password that is 72 A's and something else at the end produce exactly the same hash with the same salt. And what is pretty bad on Bcrypt developers' decision is the decision that they will just cut it. There is no error, there is no nothing, it just works. And that has consequences. And the consequences are that Devise now comes with password limit length by default of 128 characters, even though 72 bytes is the maximum value that will be used. And the worst thing is that Devise wanted to add pepper at some point. So they are adding pepper at the end of the password. And if with that limit, it means first, not whole pepper is taken into account. And second, you can leak it. Because I can create an account, put my password as 71 A's, and now only the first character of pepper will be added to the hash. So now I just iterate A, B, C, D at the end of my password, and finally I'm logged in. And there is a match. I know what is the first character of the pepper. I do the same thing for the second one, third one, and so on. And now I leaked all the pepper from the application with simple login form. So is here somebody who uses pepper in Devise? All right, so nothing to do for you. That's good. I would argue that it will be good to use it properly because, hey, it's not secure that way. But yeah, in Devise, it's not so great idea. And this comes from the small misunderstanding because Bcrypt is not a hashing function. It's password hashing function. And the big difference here is that hashing functions are supposed to take arbitrary length input and transform it to fixed sized output. If you use ever SHA-256 to do a checksum of files, you know that you can put there a few gigabytes there and you will get 32 bytes of output. Bcrypt takes fixed sized input and produces fixed sized output. And yes, I said fixed size because even though you can provide shorter password, Devise will actually make sure, sorry, not Devise, Bcrypt will make sure that it's 72 bytes always. If you ever written in C, you know that each string ends with null byte. So that will be added by default. And then when Bcrypt will find that null byte, it will repeat everything and again till it reaches 72 characters, bytes, sorry. As you can see, those are the same hashes. And the bad part is, even if there is something else after that null byte, it will be ignored because that's the end of the string for C implementation. Fortunately, the most common Bcrypt library that is used in this example doesn't allow you to put null bytes. I needed to change the bindings to C to create that slide. But why this is important, we will see a bit later. So how to fix that? The simplest solution that I would recommend is just use argent to ID if you need pepper or you want to have arbitrary length passwords. It's hashing password competition in 2015 winner. It has a limit of the length of about 4 gigabytes. So be sure to limit it because you're gonna have DOS attacks based on that long passwords. It was built with salt and pepper supported, as you were able to see in other screen. It's easy solution for new applications. You just swap one thing and it works. And it's recommended by OWASP, which I highly recommend you to take a look into. They have great sheet series about everything related to web applications. OWASP stands for Open Web Application Security Project. Other solution will be just to limit the length of the password. I mean, 72 bytes, it's pretty secure. If you don't need pepper, who cares? It works. But if for some reason you need pepper, or you believe as I that it's just needed in current world, and you need to stick with bcrypt, because Argon had some issues, mostly with performance, you can always do something with that password before putting in bcrypt. You cannot hash it, unfortunately, because then you are open for hash shacking, and that basically means that if you put the whole password in SHA-256 and then to bcrypt, I can probably find a few million of passwords or SHA-256 hashes that were never broken, and I can now just check if putting them to bcrypt doesn't result in one of your hashes. And now I just need to break that SHA-256 instead of bcrypt, which is much, much easier. So HMAC. HMAC is basically SHA-256 in that example, but with pepper, or key in normal use, but here we'll use a pepper. There are two most important things. First is that base 64 digits. HMAC returns normally bytes, so it can return null byte, which, as I showed you, is a no-go for bcrypt. And the second thing, you cannot use too long hashes because, again, 72 bytes password limit, and you need to base 64 encode that. And, well, you need to use pepper in that scenario. Other things that you can use, maybe use AS to create, if you need pepper but you don't care about passwordlet, you can use AS to encrypt the password. It has that benefit that now you can rotate your pepper. So it's even more secure. Dropbox is doing something like that, if you wanted to read about it more. But I promise you that we'll talk a bit about token-based authentication for APIs. And I have a role in my projects. Don't do security if you don't need it. So use a Devise token out if you need to do tokens for your application. It's simple opaque token solutions. No JVTs here. You don't need more crypto if you don't need it. Works great with plain Devise. Because you still maybe need to have admin panel in views or whatever. It has great configuration. It's pretty secure by default, and you can always make it more secure. And it is popular. It is more popular than many concurrent to Devise solution for whole authentication. So I highly recommend it. And they finally have normal, simple authorization header instead of 4 independent header that you needed to keep track on the front end till last week, I believe, because it was released on 10th of September. So refresh tokens and why to keep them in cookies. So why cookies? It is actually very simple to implement. Rails have support for them for I don't know how long, probably to Rails 1. And every other framework has support for them. They were battle tested for over 25 years. They are first-party citizen on your browsers. And what's even better, you control them, not front-end, which means it's harder to do something stupid with them. They can prevent leaks, because if you store long-term tokens in session storage, in local storage, things like that, all JavaScript has access to that. In cookie, you set one flag, JavaScript cannot even get access to that. And if you set them to secure, you cannot send them over HTTP. The browser will make sure that only in HTTP requests those are present, which is important, especially in a bit older browsers that still don't support HSTS and forcing HTTPS. So, tokens. That part is pretty easy, but this slide is here mostly because I wanted to talk about what tokens are. Tokens are passwords. Nothing else, nothing more. If you know it, you can do something. The same thing with a password. And that's why you should treat it as password. You shouldn't ever store tokens in plain text. Because if you have refresh tokens that are meant to be long-term tokens, if you have database leak, or maybe when you have database leak, now whoever has that leak can use those tokens to log into your application. And instead of having just read access from the leak, they have write access to user accounts. Yeah, you should probably have some expire date for them, and you probably should make sure that you don't keep too many of them in the app. As I said, cookies are easy. That's all you need to set a cookie in Rails. Basically, you do the name, the value, when it expires, and then some flags. I recommend secure, so it doesn't go over HTTP. HTTP only, so it is not accessible from JS. Send side, strict, so it's only sent to API, never anywhere else. And, well, you set the domain which set the cookie. How do you do refreshing then? You just take, again, cookie by name, parse it, because I decide on JSON there, and find it, check if it's valid. If it is, set the tokens, render success. Everyone is happy. If you work with mobile, somebody might tell you that there are issues with cookies in mobile. Just tell them to Google things, because it works. I have currently 3 mobile applications that work flawlessly with cookies. And that's the best we could done for security and simplicity in our configs. Of course, if you have cookies, you probably need CORS, especially if your API is in different domain than frontend. If you are using Ionic or something like that, Ionic is stupid because in theory it's a mobile app and CORS is for browsers, not for mobile apps, but it, for whatever reasons, follows the rules. It means that you either have to yell at your mobile developers that they need to change client from fetch or something like that to native Ionic, or you need to add localhost 3000 here so they can work with that. I would say yell at them, but decision is up to you. Important things here, you need to say credentials true. Without that, the browser will not let the app, well, it will not include cookies. And that means it won't work. But it's actually great because you can now say that cookies should be only on those 2 endpoints. So only for refresh and for login. And maybe for logout if you want to delete them. But I was talking about enumeration attacks, and I wanted to ask if you know what those are. So if somebody knows, then hands up. All right, we have some people. That's awesome. quick example of enumeration attacks on registering forms. That's Discord. And now I know that this email is in database because it's already taken. So I can just go like this through all possible emails that I have on my list because I need to check something, and I will know who has accounts and who doesn't. When these things can happen? Of course, registration forms, but every form that requires email probably as well. Password reset, confirmation reset forms. I mean, you often see that, sorry, you don't have an account, please go here and create them. Don't do that. Login forms are much rare, but it still happens. I don't know why somebody bothers to have different message for wrong credentials and wrong email, but they do. And why should you care? Well, I would say that just privacy of your user is good enough reason to care. But if you don't believe in that, then, well, maybe you shouldn't. But what if you have app that, for example, helps people with addictions? I wouldn't want to know that that app can be enumerated and now everybody will know that I struggle with alcohol addiction or things like that. There may be requirements from client, or we had information that there may be requirements from government. I don't know if that wouldn't break some HIPAA rules. So how to prevent them? Well, just change the messages. Okay, we send you an email, check your inbox. We send you confirmation link, go there. And if somebody already had an account, instead of confirmation link, just let them know, hey, you already have an account. If you forgot your password, here is the reset page. It works on every form and it's easy. But is it enough? And the answer, unfortunately, is no. Because as Norbert taught us yesterday, Galileo decided to create the concept of unit of time, and now we can measure it. Which means that I can take my email that I know doesn't have an account in given page, do 1,000 requests on password reset form, and have some graph that shows me how long more or less it takes. Then I can create an account, repeat the whole scenario, and now I can see that, oh, that's a bit longer. So let's try with other email. That is pretty close to the case when account doesn't exist, so probably it doesn't. But if it was closer to the second chart, then this means that accounts pretty much for sure exists. And that's, again, a leak. It's much more complicated, but it is. So where this time difference comes from? Well, of course, if you send email synchronously in request, that's very long time. But object initialization takes time. You can have callbacks there that take time. You are probably doing some, even waiting for Redis to get a connection from the pool, especially when I'm hitting it with thousands and thousands of requests because I'm measuring time, can take time. So how to prevent that? One solution is to, and it works for registration forms, for password reset forms, is you don't check if the account exists on request. You just schedule a job on Sidekick. We had a great presentation about Sidekick yesterday. And you do that in the job. And if the account exists, you just send them instructions, hey, you have an account. If you forget the password, you can reset it here. And if it doesn't, you create them, send the confirmation email, and it works. But this doesn't, unfortunately, work for login forms, because you cannot really do that asynchronously. It would be awesome, but hey, well, okay. You can, but not easily. the simple way is to request limit the login form. Because if I cannot create those charts, because I cannot do enough requests, nothing I can do about that. This part, it's limits by email. And it's awesome for those situations. But if somebody will find out that you are doing it like that, they may want to use it to dose your application. Because now I can go with emails and block users from login. That's why I highly recommend having an easy way to skip this email version. But of course, per IP always works. So, quick summary. If you want to use Pepper in Devise, just use Argon. And if you don't, maybe remember that password length limit, because it will be strange that you can create longer password that is even taken into account. If you want to create an API token authentication, Devise token out is your friend. And I highly recommend to refresh tokens and cookies. And for enumeration attacks, there is solution with doing that async for most of the forms. And yeah, I hope you have a great conference, and thank you very much. Any questions?
Thanks a lot. What do you think about using other services, for example, Auth0 to handle the users and the authentication instead of Devise, for example?
That's awesome, because if you don't have to store password, don't store it. It solves a lot of issues. But to be honest, at the end of the day, part of authentication is always there, because you need tokens on your side to authenticate API and things like that. So the second part of the presentation is still valid. But yeah, you know how it is in real world. Client might say you, but this is too expensive to use, and go with hand-built solution. But yeah, other providers are awesome. I mean, less passwords is always better.
If these things are broken in the package, have you tried like opening an issue on the repo and talking to the guys there to fix it for everybody, maybe?
I tried to write an email because I didn't really want to talk about leaking Pepper publicly at first. But because they didn't reply for 3 months already, I feel justified to talk to you about that. And yeah, I will probably try to find time and do something about that. But to be honest, it's not that easy. Because the solutions that I showed you are great for single project. But Devise needs to think about what about those people who can only update a package. Creating API breaking changes in security libraries is a terrible idea. That's why OpenSSL still supports 25 years old APIs, because a lot of people need them, and it's responsible to do it that way.
Gotcha. Well, I think it's better to like break some APIs or force somebody to update it than to have like bad security. But
yeah, that for the Pepper, sure, I would just tell them to stop using that.
Yeah, that's
because perfect. Yeah, but there are some things that are not that simple, and I can understand why they will take some time to figure out less painful migration path.
Gotcha. Thank you. Very nice talk.
Thanks. All right, so thank you very much.